In this video, we're going to evaluate the integral of the natural log of 2x over x squared. Now, the majority of the time, this type of integral involving natural log will usually involve integration by parts. Some cases, it could be a standard u substitution, but I'm going to try integration by parts to start off with. When I pick my u, it should be something that we can differentiate. Natural log be fine. So we let u equal to ln of 2x, then du would be the derivative of this, and the derivative of a natural log function. Whatever you have as the argument goes in the denominator. That'll be 2x. And then in the numerator, it'll be the derivative of that argument. Derivative of 2x is 2. So these cancel out. So we get du will equal to 1 over x dx. 1 over x squared dx. So that'll be dv and will equal to 1 over x squared dx. So we integrate this with respect to v. On the left side, it'll give me v. And on the right side, we can write this as x to the negative 1, or negative 2, I should say. Add 1 to the exponent, it's be negative 2. So 1 over x squared can be written as x to the negative 2. We add 1 to the negative 2, we get negative 1. And then divide the coefficient by that, we get a minus over here. And this will equal to, for the formula, integration parts, it starts off, whatever you got for u, we let u equal ln of 2x. So it'll be ln of 2x, that's multiplied by v, and v is equal to minus x to the negative 1. And it's minus, so u times v. I have it in different order, but it doesn't matter whether I put it as vu or uv. This was by u here, and then the minus x to the negative 1, that's my v. And then that's minus, in the formula, is minus v here, and v is minus x to the negative 1. And that's multiplied by du, or du is right here. And I'll write that as 1 over x, I'll write it as x to the negative 1. And then it's the dx here. So let's rewrite this in. Got minus x to the negative 1, x to the negative 1. That becomes negative 2, x to the negative 2. So let me just cancel this out. Make this a negative 2. And that's going to be dx. And this is equal to, again, minus x to the negative 1. Natural log of 2x. And then we have double negative here. So that'll be a plus, but then when we integrate this, we have to add 1 to the exponent here. It gives us a negative. So these cancel out, but then we have a negative still because we add 1 here. That gives me with minus x to the negative 1 plus the constant of integration. And that's pretty much your answer here. But you might see the answer written differently. So what I'll do, just to match the answer that they give for this, I'm going to take out negative x to the negative 1. So take out minus x to the negative 1. That leaves me with ln of 2x, natural log of 2x. Take a minus x to the negative 1, then that'll leave me with a plus 1 plus the constant of integration. So quick review here with integration by parts. You pick from the integral, pick something you can differentiate. Natural log, more difficult to integrate than differentiate. So u is equal to ln of 2x. Your dv is something you can integrate easily. So dv is 1 over x squared. From that you find v, and then you can finish the problem. The first part of the answer is the product of u and v minus the integral. And then in here, for the integrand, you have the whatever v is right here, minus x to the negative 1. Of course, we computed that out, remember? Here, we had a minus x to the negative 1 multiplied by du. which was 1 over x. That's how we got the minus x to the negative 2. Then we integrated, we got this, and then we factored out a x to the negative 1 here. So the final answer is minus x to the negative 1, parentheses, natural log of 2x plus 1, plus the constant of integration. Thanks for watching. We'll see you next time.